Alright, so the next question is the wave function of a particle is given by this equation. Okay. Relative to an initial reference time of t is equals to 0, the probability of finding the particle at a later time at a point x is equals to 0. So the question is not difficult, just break down the question into small parts and analyze what the question is trying to convey. So what they have asked, basically they have mentioned a wave function, okay, relative to an initial reference point. So if we start from t is equals to 0, what's going to be the probability at a later time t is equals to pi 4 omega at a given point? So basically time is changing but the position is fixed. If x is equals to 0, how probability will vary from time t is equals to 0 to time t is equals to pi by 4 pi? That is what we need to figure out. So if the position is fixed, that is x is equals to 0, if the particle is present over here at x is equals to 0, how the probability will vary if we start from time t is equals to 0 to time pi by 4 omega. That is what we need to figure out. Relative probability. Will it increase, decrease, stays the same, or may increase or decrease depending upon the value of k. Okay, that is what we need to figure out. So what we can do over here, see, what is probability actually? How we can find out the probability? Probability is minus infinity to plus infinity psi star psi theta. Okay, that's how we actually find out the probability, keeping the given equation. Okay, so the equation is a function of basically time and position, and it's of trigonometric sign. Okay, so basically it's a sine wave function. So can I write, let's say, sine, anything, bx, let's say bx. Okay, so it is basically sine bx. So we can say probability is minus infinity to plus infinity sine square something. Okay, let's say bx dx. Okay, this is going to be the probability. What we need to do, we need to figure out the change in the probability at two different times if the position is fixed. All right, so first thing what we need to do in this question is, if t is equals to 0, what is the expression of x? If t is equals to pi by 4 omega, what would be the expression of x? Okay, first thing we need to figure out the value of x or the expression of x. Okay, x is the function over here. So all I need to do is we need to figure out the zeros. Okay, at which particular function, at which particular the value of x, the function would be 0. That is what we need to figure out. So if sine k x minus pi by 4k plus omega t equals to 0. Okay, we need to figure out the value of x. So we would be finding out the zeros of the function. So when the value would be 0 when it's a function of n pi, right? Sine would be 0 when it's an integral function of n pi, like n can be 0, 1, 2, 3 and so on. Okay, it would be an integral multiple of n pi. So if I just equate these two equations, so k x minus pi 4k plus omega t is equals to n pi, right? Let's solve this question. So kx minus pi by 4, k and k would be cancelled out, plus omega t equals to n pi. So this is the equation. Okay, kx minus pi by 4 plus omega t equals to n pi, right? Let's rub it this part. Okay, and let's substitute the value of two different times, that is t equals to 0 and t is equals to pi by 4 omega. So this is the overall equation, kx minus pi by 4 plus omega t equals to n pi. We need to figure out the value of x at two different times. Okay, so if time is equals to 0 and time is equals to pi by 4 omega, therefore when time is equals to 0, kx minus pi by 4 plus 0, right, is equals to n pi. So we can say x is equals to n pi plus pi by 4. Okay, kx is equals to n pi plus pi by 4. So let's take k to the denominator, n pi by k plus 4 by pi by 4 k. Okay, so basically the value is, this is the value. Okay, this is the value of x when t is equals to 0, right? When t is equals to pi by 4 omega, what would be the value of x? Let's find out. Omega into pi by 4 omega, right, is equals to n pi. So therefore, omega and omega would be cancelled out, minus pi by 4 and plus pi by 4 would be cancelled out. So kx is equals to n pi. So we can say x is equals to n pi by k. Okay, what we have done over here, at two different intervals, two different times, we have figured out the value of x, right? So what we have figured out, that through the equation, when time is equals to 0, x expression is n pi by k plus pi by 4k, and when time is equals to pi by 4 omega, x would be n pi by k. Okay, so that means at these two values of x, the function would be 0, right? That is what we need to figure out. These are the zeros of x. At time t is equals to 0, the sine function has zeros at x equals to n pi by k plus pi by 4k. And when time is equals to pi by 4 omega, the sine function has zeros at 0 at n pi by x. Okay. Now, how probability will vary at x is equals to 0 for these two time intervals. Okay, so what is probability? Minus infinity to plus infinity sine square bx. Okay, how probability will vary when x is equals to 0, right? See, when x is equals to 0, what we need to figure out, see, if when time t is equals to 0 and x is equals to 0, right? How x can be 0? See, how x can be 0? Let's see if this particular value is 0. Okay, so all I need to say is this value n pi by x, this value will give you this. Basically you'll get the value of 0. Wave function is equals to 0 because it's an integral multiple of n pi. Okay, sine wave function has an integral multiple of n pi, so this value will actually give you 0. But what about this value? Still x has some value, okay, pi by 4k, so it will give you some probability. This part will definitely give you 0 because it's an integral multiple of n pi. Okay, and when sine is integral multiple of n pi, the value goes to 0. That is true, the probability goes to 0 for this particular part, but still it has some part. Okay, still some part of the function is left. Okay, so all I can say is when time t is equals to 0 and x is equals to 0, the probability will not be equals to 0, right? The value will have some probability. Okay, uh, for the sine function, because irrespective of n pi plus x, it is having some other part as well, that is pi by 4k. But when time is equals to 4 by pi by 4 omega, when time is equals to pi by 4 omega at x is equals to 0, the probability will go to 0, right? The probability will go to 0. Are you getting the point? Okay, because what I need to say over here is it's nothing, it is actually the integral. Okay, basically it's actually the integral of n pi, and the sine square n pi will actually give you 0 probability at the end because it's the integral multiple of 0. Okay, so that is how we can actually relate the point. Okay, so for x is equals to 0, time t is equals to 0, it will have non-zero probability. But x is equals to 0, time is equals to pi by 4 pi, it will have 0 probability. So from non-zero to 0, the probability will decrease. Okay, so that is why, the option B is correct. It says at time t is equals to 0, the sine function has zeros as this, as we found out. Okay, and time t is equals to pi by 4 omega, the zeros are shifted to this. Thus at x is equals to 0, the probability is non-zero initially because it has some pi by 4k wala, extra part, and 0 at a later point. Okay, so that's how we can understand this concept. Okay, though it's not a difficult question, all you need to do is you have to devote some time to the question, see what options are saying, try to correlate the answer with the given options, and then you can land up to the correct answer. Okay, this is the basic set of TIFR questions. If you can understand options, given options really well, okay, I'm sure you can get to the correct answer. Okay, that's how you have answer in front of you. All you need to just find out the way to get to that particular answer. That is what we need to do in this particular case. Okay, the question is pretty simple. We need to figure out the correct answer first. Okay, then actually can get to the explanation that why option B is the correct answer. All right.